Okay, so here's a typical, find the value of K type of problem. Let's start by taking that system of equations, turning it into a matrix version of that system. And so, of course, the first step here would be to rewrite this in matrix form. And each row is going to be its own coefficients here, right? So 1x, 1y, z has a k in front of it, so I don't know how many there are, but I'm going to call it k. And the augmented side, there's just a 2 over there. Okay. And the second row is 3x, 4y, 2z, but now I have a k on the augmented side. It's the same k, right? Same unknown. And on the bottom row, I've got a 2, a 3, a -1, and a 1. So you guys agree that's the matrix that goes along with this system? We just don't know what the value of k is, right? And depending on the value of k, it'll determine how many solutions we get in our system. All right. Let's proceed as if that k was just some number and work ourselves into echelon form. All right. So we'll do row reduction steps until we get to echelon form. Okay. So let's do that. So the first steps I would do would be to use that first column and try to get zeros here and here, right? So where the 3 and the 2 are, that's where you want to knock those out. And we'll use the top row to do that. Luckily, there's already a 1 in the upper left corner, makes our lives easy, right? So let's go ahead and do a couple of row reduction steps. I'll do row 2, and I'll subtract 3 row 1s from that. And then I'll do row 3 as well on this step, just to save us a little bit of time. I'll take row 3 and subtract 2 row 1s, right? So I'm going to knock out those ones in that first column. So if I do those steps, here's what my new matrix looks like. And here we have to be pretty careful when we put this together. Top row is not changing, so I'm going to recopy that top row and write my K so it looks like a K. And then here's where we have to be a little careful. The numbers are going to work out fine. So 3 minus 3 is 0, just like we expected. 4 minus 3 times 1, so 4 minus 3 is 1. Great. Here's where it gets a little tricky. You just have to keep track of things, right? I don't know what K is, but whatever it is, I'm going to multiply it by 3 and subtract from 2. So I'll go 2 minus 3K. Does that piece make sense? So the value of K determines what that's going to come out to be, but whatever it is, I'm doing what it says to do in that row reduction step. All right. And again, I'm taking row 2 and I'm subtracting 3 of row 1. So this will be K minus 3 times 2. So K minus 6 would go here. And that's where we are. So at that point, we've got row 2 figured out. Let's do row 3, same stuff. 2 minus 2 times 1, so that's 2 minus 2, that's 0. 3 minus 2 times 1, that's a 1. And then -1 minus 2 times k. So -1 minus 2k would go in that bottom third slot. Okay. And I'm doing 1 minus 2 times 2. So that's 1 minus 4. This would be a -3 here. So far we've got the first column taken care of. We've done our row reduction steps so that I get a pivot column in the first column. All right. Next step would be to move over to the next column, try to get 0 down here. And then we do our typical row reduction steps. So I'm going to go ahead and take row 3 and subtract row 2 and see what we get. All right, so that should give me the 0 where I want it. And then the other pieces should fall right into place. So I'm going to recopy the first row. That's not changing. I'm going to recopy the second row. That's not changing. And the third row is where I'm calculating. The 0 stays 0. 1 minus 1 is 0. Now I have to be careful, right? I'm doing -1 minus 2k minus 2 minus 3k. So -1 minus 2k minus 2 minus 3k. So you piece that together and you end up with what? K minus 3? I think that's k minus 3. All right. And if I do the same thing with the other piece, it's going to be -3 minus k minus 6. Which is going to be 3 minus k. Let me do this. I'm going to go -k plus 3. Just so I can put them all on the same footing. That all work out for you guys? You follow it? We're just combining the values just the way we normally would. We just don't know what k is, so we have to leave it k, but we can still do the algebra. All right. At this point, we're in echelon form. Okay. So here it is in echelon form. Because I've got this pivot position here, here, and there. All right. So what we want to do with this is now figure out what does it take to make this system consistent so that it has solutions? What does it take to make it a unique solution? What does it take to get a free variable? That type of thing. All right. So for this particular case, there's kind of one special value of k that's going to make things interesting, right? And then other values of k are going to make it less interesting. All right. Tell me a value of k that makes this interesting. How many free variables do I have in this problem? Okay, it looks like there's no free variables because it looks like I've got a pivot in all three of these positions, right? But a pivot is going to be a non-zero number, right? So I'm going to have no free variables unless k is equal to what value? Yeah, 3, right? That's the sort of obvious number that would make things interesting here. So if k is equal to 3, then some stuff drops out to 0, right? So I'm going to write down something about that. So I want to say unless k equals 3, we have no free variables. Which means how many solutions are we going to get? So if we don't have any free variables, how many solutions do we get? So if there's no free variables, what can you say about the number of solutions? Yeah, one unique solution is all you're going to get, if you get any solutions at all, right? So let's say this, if there's no free variables, you'll get at most one solution. In this case, can we guarantee that you're going to get at least one solution? Is there any way to make this system inconsistent? That's the other question you got to ask yourself. So is there any way things can go wrong here? Is there some value of K that makes this system not work out? How can you tell if your system doesn't work? If you have an inconsistency or if you have an inconsistent system? Like, what does the matrix look like if you have an inconsistent system? So I'm going to write down that we have a unique solution when we have no free variables. I just want to make sure we're clear that we have to have a solution in order to have a unique solution. So if this were going to be inconsistent, what would that bottom row look like? I want to say we know there's at least one solution because that bottom row is either 0, 0, some non-zero thing, some other non-zero thing, or all zeros, right? We know there's at least one solution. Our bottom row is either all zeros or it's 0, 0. I'm just going to put like number. In fact, negative number. All right. So the fact that that bottom right on the augmented side there is exactly the opposite of what I've got in the box there, the K minus 3, those two are either both 0 or neither of them are 0. All right. In order for it to be inconsistent, I'd have to be, I'll say, to have no solutions we'd have something like 0, 0, 0, and then non-zero thing for that bottom row. That doesn't happen here. Okay. So as far as being an inconsistent system, it's not going to happen in this case. All right. It's either going to be one solution or an infinite number of solutions. All right. So if K is not equal to 3, we get a unique solution. But if K does equal 3, we have one free variable. That's supposed to be 1. So we'll get a one-dimensional solution. All right. So there's sort of our results here. If K is not equal to 3, we get a unique solution. In K equal to 3 case, we get an infinite solution. So that's kind of our possibilities in this problem. All right. But does the process make sense? You're going to go through and just work through your row reduction as if that K was just some number and just carry it along, and you'll get an equation that you can solve. In our case, the equation was easy. It was just K minus 3 equals 0. That's the thing you're solving to sort of figure out where the interesting case is. All right. So when K is equal to 3, that bottom row all goes to zeros, and you get your free variable. The Z would be the free variable. The third column would be the free variable in that case. If we want to, we could write down the solutions in terms of Z when you have that K equal to 3 case. Otherwise, you're just going to get some numbers for X, Y, and Z. All right, unique solution. So that's the type of thing they're going to ask you on those find the K problems. Just reduce it down as if the K was just a number, and carry it along, and you should get some equation to work with in that bottom row. And it should be pretty straightforward once you get to there. All right, so that type of thing is what you're up against. Make sure you can sort of work through the logic of how you get a unique solution or not in those cases.